Ya, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Okay, can you hear my voice clearly?
Yes.
Okay, so let's begin. Okay, for someone who not enter this session yet, I will record it and I put in you learn later. Okay, so this is our second meeting after a long break. Okay, hopefully everyone is okay. Your area is not you are not in the banjir area. Ada ke? Is there anyone mangsa banjir? Okay, so let's begin with our session. Okay, for today, previously we learned about what we call the forget about the name. Okay, which is analysis for the introduction to multivariate data analysis. Okay. So for today, I plan to do some exercise which is we learn introduction about R, how to read data from R and how to save it and how to make a data cleaning and tidying our data. Okay, because I see in the lab exercise you have to do a cleaning data before you do analysis. And for one question in the lab for individual work, which is you have to do cleaning and you have to separate data, you have to make there is a mix between the data type. You have to determine what data type you have used. Okay, that's topic we will cover tonight. Okay, it's all about R, which is how to clean, read, and write data using R. Okay, let us start with our lecture today. Okay, so first I will share this. Okay, actually this slide I modify a bit. This is from the Dr. Ravi from UKM. He teach about how to use getting and cleaning data using R. Okay, so here in this topic we will learn about how to read and write. Okay, it's all about syntax. Actually, if you familiar with the read data, which is if you familiar with something Python or something like MATLAB, if you want to read like one data type, whether it is data itself or it is one type of image, first you have to read their syntax, which is you have to read it so that that particular language will know that you want to read that particular data. After that, if you want to save it, there is a function like MATLAB, similar like R, which is you have to write it, whether you want to write it in what format. If it is in Excel.xlsx, or if you want to save it in text, so .txt or something like that. Okay, so here first, can you see my slide? Okay, here this is how to store a data. Okay, storing data. Every R object can be stored into the register from a file with the command save and load. Okay, first you have to use these commands, whether it is save or load. Okay, first thing you have to do here is I want you to look at the ulearn, which under my name, under multivariate data analysis, there is R material. You have to download it first. Okay. First, I will share the. Can you see my ULEN? So let us go to ULEN first. Sorry. Okay. Because after this, we will go for R session. Okay.
Dr. Zurani.
Uh-huh.
Oh yeah. Okay, I can
Okay.
see now.
Okay. Okay, this is my ULEN. Now, under Dr. Fauzia, there is my name, Introduction to Multivariate Data Analysis. So here is R material. This is the link for R material from my Dropbox. Okay, first you have to download all the material here, which is, you can download it. Where is the, this is how to share. Kejap, kejap, Okay, first you have to download. Maybe you, okay, then download all this. For today, download. Okay, now I already have this all, and not, I not going to download it because I already have. So I give some time to you to download. So today we'll focus on day 3. Okay, this two thing, and okay, here we will do this exercise. Okay, so my advice is for you to download all this material first. Okay, I give some time lah to you to download. Okay, other example. This is about missing data. Okay, so download it first. So everybody done the downloading, please let me know. Okay. And you already download the you already install R, right, in your machine. Okay, so let us continue. Okay, this is how to store a data. Every R object can be stored into a restored from a file. The command save and load. This use the XDR data representation standard of Sun Microsystem and others. Is portable between MS Windows, Unix, and Mac. Okay, now this is the syntax, which is if you want to save it, we save it and we give it a name. Okay, then this is the file that you want to save and you want to load it. This is the syntax. Okay, then okay, importing and exporting data. There are many ways to get data into R and out of R. Actually, for this course, we focus on R. If you are more familiar using other language for project 1 or project 2 later, you may use the other language also. Okay. Then most program like Excel as well as human know how to deal with rectangular table in the form of tab delimited text file. Okay, this is how we read a delimited text file, which is we read it and read dot delim means that we tab delimited text file, which is we read it from that. Okay, and this is the syntax. Okay, just for today lecture is not going to be long. Supposed to be short. But first, I will discuss what we are going to do in the lab session later. Okay, now for importing data. Okay, type conversion. Okay, by default, the read function try to guess and auto-convert the data type of the different column. Okay, there are options is called classes to control this read the only help. Okay, so special character, the delimiter character like space, comma, and tabulator, and the end of line character cannot be part of the data field. Okay, so to circumvent this, text may be quote. However, if this option is used, the default, then the code character themselves cannot be part of data field except if they themselves are with quote. Okay, now understand the convention, your input file use and set of quote option accordingly. Okay, the most important thing is if we have data, we have to know our data. Is there any step that we need to do in cleaning our data? We know our data well and we know what we are going to do. That's the important thing. Okay. So this is by importing data in R. Okay. If you want to import data, can use this. Okay, if you want to scan it, read it, okay, there is a lot of data type, which is you can use data directly from Excel. It's uh, frequently we see data in Excel, but there is a data also from the website. You may use data from the website. You can read the data from the website. Okay, like one task in your lab, you have to read the data. The data is inside the website, so you have to read. Then what you going to find it? How to read the data from the website. Okay, so the requirement on the form of set of data are sometimes quite strict, so it is better to modify input file to satisfy this requirement. Okay, so it up to you whether you want to save it first, like for in a text file, or then convert it back to the Excel. Is up to you. Or you want simply read it from the website. It's much the process is more easier for you. It's up to you. Okay, but we know what to do first. Okay, then after that, this is the function scan. If you want to scan whether this function most flexible, it can be used to read logical, integer, numeric, complex character, raw data, and list. Okay, this is how we scan. What is file? Okay, this is the explanation what is file is. The name of file which the data are to be read from, and what is the type of data to be read, whether it is logical, integer, numeric. We can if we have one data, you can determine what type you want to read. Okay, and n is referring to the maximum number of data value to be read. Okay, for example, if we have a lot of data, if we involve in a big data, but first we want to know the initial condition, which is we want to know the specific data only. So we don't want to see a lot of data. You can determine the value of n here. Okay, then in this scan also we have sep. This is the separated character, and that DEC decimal point that you want to going to use, and skip is uh how many line that you want to skip, because sometimes there is title inside that data. We don't want to focus on that. We want to skip to line number 5, which is it involve the data itself. Okay, you can skip it also. And na.string is we want to know whether inside our data is there any missing value. Okay, a lot of data project we involve, there is a lot of missing value. Okay, how to deal with it? Okay, there's a lot of research about how to deal with missing value. What to do with missing value? Okay, this is the function to read table. Okay, inside this read table, we have header, which is we want to know whether the file contain the name of variable and first line. Okay, what is the header? On the first line, then separator also, decimal is decimal point, row dot name, and column. Okay, maybe you can write it by yourself after this. And this is one type of input file format, which is, okay, this is what we call the row name. and this is the column name. Okay, then, okay, this is one of example, and this is STRA ni. STRA, which is our A is from we name this table as A. We define this table as A. Then we want to know the structure, which is the type. Okay, so we know that n dot amir is integer. Europe is also integer. That's the type. And Asia is also integer type inside it. Okay, okay. And this all the data type is integer int. Okay, then this is the read dot table function. Okay, to read entire data directly, the external file will normally have a special form. The first line of the file should have a name for each variable in the data frame. Each additional line of the file has its first item, a row label, and the value for each variable. Okay, this is a row, and this is a column first, and this is a row label. Okay, 1, 2, 3. Okay, numeric variable and non-numeric variable is a factor. Okay, then this is how we read a table. Okay, we have house.data, then we name it to house price. Okay, the file name is name input.data, house.data. Suppose the data vector are equal of length and are to be read in a parallel. Suppose there are three vector, that the first of mode character and the remaining two of the mode numeric. Okay, then the function scan. Like previously, we want to know our data. We want to get uh, closer with our data. We use the function scan. Okay, here. Then this is how we do the syntax with a scan. And we want to know about input.dat. And here in the list of ID, X is equal to 0 and Y is equal to 0. Okay, then this is we read the file format CSV, comma separating value. Okay, what is the difference between CSV and CSV2 is the decimal point is dot. Okay, then is the variant used in country that use a commas as decimal point and semicolon as a field separator. This is, we have to know our data. If our data involves something like comma and semicolon, we have to read it by read.csv2. Okay. Then this is where to read the read.delimiter just now and read.delim2. Okay. This is the separator, and if true, then in case the row have unequal length, blank field and implicitly added. Okay, after this we will see all these function will be used in a lab session after this. Okay, this is categorical function, which is object, file and separator. Okay, then just go through this. Okay, how to write a data frame. If you want to write a data, okay, from scratch, okay, we want to write a data, you can do it by write.table. Data frame on object that can be concatenated to a data frame with a row and label and column label. Okay, this is function write. Okay, this is the syntax, which is X is data to be written out. Okay, then we have file to write. And n column, the number of column to be write in data in. And append is if true, the data X are append to the file. And separator, a string used to separate column. Using separator, okay, /t give tab delimited output default is white space. Okay, like other syntax of from other language, which is we use this as a like a new line, something like that. Can? Okay, then this is a write table. Okay, all the syntax about write table. We have to know, okay, this is row dot name and column dot name is indicating whether the row or column name of X to be written along with X or character vector of row column name to be written. Okay, which is row name is equal to true and column name is equal to true. NA is the string used to use for missing value in the data. NA dot string like previous example. Okay, here. Okay, the function to write CSV and CSV2. Like previously, which is CSV, it involves comma, and CSV2, it involves semicolon. Okay, then reading Excel file. Okay, an Excel file can contain many sheet. Okay, in one Excel file, you can see bottom of Excel file there is sheet 1, sheet 2 kan. Okay, can contain formula, macros and so on. Not all reader can manage this. Instead of importing the data content in .xlz file in R, it would be easier if you export data of XLZ file in a text file. Okay, this is this author suggestion, which is after you export data of Excel file in a text file in tab delimited or comma separated form. Okay, you use R function read delim or read CSV to import the text file into the R workspace. Okay, then this is all about the syntax and function in read and write data using R. Okay, now let's begin with our exercise. Okay, you may use the, okay, let me share my window first. Okay, you may use the folder that you download just now, or you can open inside R itself. Okay, first I will, okay, this is my, where is my file just now? Okay, from this. Okay, the true material just now I'm saving it in here. Then I want to do the read and write data file here. Okay, go to the day 3 material, day 3 P7 here. Okay, there is R function there. Okay, can you see it? You may click it from here, and it will go to the R environment. Okay, or you can open your R Studio, then you can open file from here. You may find your file just now. It's inside the day 3 material. And here is the day 3, the similar file there. Whether you want to double click from the um, folder, or you want to simply open it from here. Okay, so far so good. Okay, now you can see that from my folder, I have exercise 3 dot Excel file here. Okay, we want to read it, and after that there's some work that we want to do, whether we want to save it back or to .dat file or something. Okay, now we are already in the R environment. Okay, first you have to know that your working directory, this is the syntax for get working directory. We want to know where are you now. Okay, just click the cursor here, then click run. Okay, now you know that you are in the, for me, I'm in the, in my C Dropbox. Okay, this is my file location. Okay, make sure you are using this. Or is there someone not in this working environment in this working directory. Okay, if you want to change it into in your working directory now, please go to the session and set working directory. Okay, whether you want to choose directory that you it's like this, I'm here, or your R is by default in your document, you may change it into your working directory, which is where you save your file just now. Or you simply can set a working directory by clicking the source file location here. It will automatically change the working directory into your active file here. Okay, so far so good. Is it okay? Okay, now. Okay, after we do the working directory here, so we know that we are in our file is there. Then you can okay, this is how we assign our table into my.data.frame. I name it as my.data.frame after read the table exercise 1.dat. Okay, this is the skip one, which is I skip one line, and this is header T. Okay, now just run it. Okay, you can see the bottom here. Okay, then this is what we want to know our data. What is head of our data? Okay, you may run it. Okay.
Sorry, Dr. Zuraini.
Okay.
I don't know what happened. I have the error in head.
You are
The object my.data frame not found.
my.data frame not found. My.data frame not found. Okay, may I know your get working directory is the data the file P3 P7 right file.r is there?
It is at OneDrive documents.
Okay, OneDrive document. Okay, OneDrive. Okay, then maybe you can share your. I'm stop sharing. Maybe you can share your.
I'm using because I'm using two laptops now.
Okay, okay. Uh-huh. Okay, so first you make sure that you are using the current working, which is your file is there. Get
Isa,
WD.
Isa, you say run which line first?
The first line. Isa. Apa?
Isa, which line you mean?
Isa.
Or select both line. Okay, let me try. Because I click at the line number 7 and run.
Oh, you have to know your working directory first.
So what will be the correct working directory in this case?
Okay, for me, my file is in here. Okay, like you can see from this is my file, right? And you can see my working directory when I run the get wd here. I run it again. Okay, this is where my file located, which is if you can see from my window here. Okay, this is my file location. It's same like here.
Sima, your error was you cannot find the my.data.frame, is it?
Yes.
You highlight 6 and 7 and then you run again.
Okay. Yeah, I think it is the same. No such
Same,
file or directory.
Okay.
I think I'm trying to set the
Working directory.
working directory.
Okay,
To
first,
source file location, right? Okay. Yeah, I found it already. Okay.
Okay, then you can run the number 6 and 7, right?
Yeah, I got the same result like you
Ah,
for
okay.
1 to 6. Okay.
Okay.
Thank you.
Okay. Welcome. Okay. So now you can see that from the head, this is the head of our data, which is we take only 6 data. Okay, if you want to see the full data of our what is exercise 1 dot that, you may clear it by here. Then we can see that we have 10 line of data, but if you use head, we only display 6. Okay, it is because if you have a lot of data, we want to know our data first, you just see the head first. No need to see all the data. Okay, this is the example of data my.data.frame from exercise 1 dot that just now. Okay, okay, it is here from the tab here. Okay, back to the main here file, which is our file just now. Okay, then we go to exercise 2. Okay, we read exercise 2. Okay, this is separator, that's involve separator and decimal. Okay, so we can see this is the second we read from exercise 2 dot that, but we use the same name. Okay, we run it. Okay, then we can see that our this the data is the recent one, which is it replaced the previous one because we use the same name. Okay, then this is where what the data look like. We use head here. Okay, then this is the data. Okay, then we know that our data here only involve 3 line. Okay, so that because it show only 3 line here. Okay, then here CSV. There is come to the CSV my.data. Okay, here CSV we skip 2 line. Okay, we run it. Okay, if you want to know our data, you may see from the folder just now. Oh, okay, so we run it. Okay, this is where we define our exercise.csv as my.data. Then you can see how our data look like. Okay, my.data, you can see that there is 2, because of this 6 line is long row, which is if you can see this data have until variable 10, which is this is a variable 10. Okay, so it will uh, continue below. Okay, then this is the head, which is this is view my data because of previously I clicked this my data. We want to know our data. Okay, then here we read exercise 3, skip 2, -1. Okay, then we read it. Then we can head of my.data now, it become white. Okay. 0. Okay. Okay, you may see your previous data exercise.3 here. Okay. This is exercise 3.csv just now. Okay, because we skip 3 line because we want to focus on the just now it skip how many line? Okay, skip 2 because we go to the line 3, then we skip 2. Then this is the head of our data, so it will read until 6 column, and this is all the command. Then you use scan. Okay, what is the scan? Okay, first we run line number 21. Okay, we name it as F1. Okay. Then we want to scan F1, what lines and skip. Okay, refer to the note just now. What is what and line and skip one. Okay. Okay, we read 6 items. And this is my .names data, which is result. Then, okay, you can see this kind of data here. Okay, it's involved result 1970. Okay, then we read this table F1. Okay, my data, we read this table. Okay, then we can see our data inside a table. Okay, here, table F1. Then this is the function where you want to close F1. Okay. If you want to find if you stuck or you want to know about a command, okay, you just can find it here. Okay, if you want to know about paste, you just type it here, then you know what is the function paste. Okay, this is the detail of this function. Okay. Now we paste this my name column 1, 3, 5 and my name C246 into my names. Okay. Then we can see our my name. Okay, this is my name. Okay. Okay. You may see the difference between my name previously and this kind of my name. It is like it combine it, right? Then we name it as names my data, and we define my name into the names and bracket my data, and you can see my data here. Okay, then it will represent the 13 previously. It is 13, 15, 23 under the column V1, right? So we replace V1 with result 1970, result 1981, and result 1991. Okay. We combine these two and we replace the header for this V1, V2, V3 with this name. Okay, now use scan to read data from exercise 4B. Okay, here. Okay, we have a list. Then here you have character 2. Then we can see F1 file. Okay, we open it. F1. Okay. Then inside this F1, we skip line 1 and we name it as my name's 1. Okay, we read one item and lines 1. And what is this item? We can view it by call the name of my name's 1. We want to see what is our scan just now. Okay, it is A. And if we look at and line 1, if scan it, my data 1, okay, and we read 3 items here. Okay, then what is inside my data 1? Okay, it is 1, 2, 3. Okay, now Here is my names too. We scan it. Okay. Okay. There is read 2. Then it is B. Okay. After this, you can see what is my name actually. Okay. Then it is my data 2 metric. This is metric with 4 and row 4. Okay. Look at my data 2. Read 12 item and it is row 4. Okay, which is we have 4 row here, and we can see what is my names is actually, and my dot name is actually AB. Okay, my names is involved A and B. And what is my data? This is my data. Okay, that's why when we want to scan line 1 in my data, it is 3 item, which is 1, 2, 3. 1, 2, 3. Okay, this is how we want to scan only that particular line to analyze. Okay, so actually inside this my name, there's involved 2 things, which is AB, and inside this data, this is one a matrix. So the scan here is we want to find the specific line. Okay, then this is we close F1. Just now we create F1. This is F1 that we create. You open it, then you may close it. Okay. Yeah, when you do the individual lab, later you will get more familiar with the syntax of R. Okay. Actually, there is a lot of forum that involve in R. If you want to read something like you can ask inside the forum or you can search inside the forum. That's how I learn to do a coding. That's me because I'm a mathematics student and I'm not familiar with the code. And previously I have to do Java and do a support vector machine for Java, and I involve a lot of forum. I ask inside the forum for help. That's how my study, the history of my study for PhD, because I involve a lot of Java. I'm not useful, not involved in Java well while I'm doing master and degree. So I get used to ask inside the forum. Okay, then this is name, my data. Okay. We assign this my dot name as names my data, and then we can know what is my dot data. Okay. Then this is my dot data, which is my dot data is involved. Okay, just now my dot name. Inside my dot name, we put we combine these two. Like previously we do like this. We combine this result with this metric. So we are using something like this command, right? So now it's same, which is we have A, B, and we have one metric. We want to combine my name into this with the metric, so that that's how we can see our my dot data, which is A, it is involve 1, 2, 3, and B, it is in the metric. Okay, then this exercise 5 is to write my dot data to exercise 5.txt, then append additional data to same file. Okay, seed. Okay, if you not familiar with it, can see inside here, it's something like randomize the number. We want to randomize. We want to create a random number generation. This is the function set.seed here. Okay, now here we create a data frame, okay, which is x is r norm 10 and y is r norm 10 plus 5, and z is r chi square 10 1. Okay, we create a data frame here, name it as my dot data. Okay, just now we already run this set.seed. Okay, So we create a random number, and this is the data frame that we want to create. Okay, then we can see my dot data look like. Okay, this is the value from X, Y, and Z generated from the random number. Okay, then this is additional data that we create, which is X is R norm 3. Okay, this is additional data. And you can see this additional data that we create is involved, okay, 3 line. Okay, because of 3. Okay, then we want to write a table exercise 5.txt. Now, from my data just now, we want to write a table. We name it as exercise 5.txt. Okay, then this is the right table. We write table for additional data also. Then this is how we write a table from the data that we generate, and we name it as exercise 5.txt. Okay, you may see your data from exercise 5.txt here. Okay, you may see this kind of data that you create just now. Previously, there is no file exercise 5, and now we have this file, and the number is from here that you created. Okay, then so far so good. Okay, you may see my recorded version after this if you want to see it again. Okay, then we set another randomized number here. Then we name it as my data. Okay, then we write it as my.data exercise 6.cmv. We write it as CSV file. Okay. Okay, this is my.data. Okay, we run it. Okay, this is the data from this data frame that we created, and we write this CSV file, exercise 6.csv. Okay, now we have this exercise 6. Actually, this folder that I created, I already run the line so that there is exercise 6. If your folder is empty just now, you may see that exercise 6 is there. Where is exercise 6? .csv, my data exercise 6, right? Where is exercise 6 here? Ada tak? Okay. This is right CSV file, right? Yeah, ada lah. You can see this is variable. Okay, so we may see that this is the exercise 6. Okay, this is the data 3408 and until 10. Negative 0, 1, 2, 3, 0, 1. Okay. Okay, then here for exercise 7A, we name our, we create a data frame, letter A, okay, and B is 1 until 5. Okay, look what data that we created here. Okay, my.data. Okay, actually, a letter A, which is letter 1, letter, which is letter A until E, then B is 1 until 5. Okay, then we want to write a table, which is this table is 7a.txt. We want to save all this data into 7a.txt. We write table, then separator, row name false. Okay, then here 7a.txt. Okay, this is 7a.txt, which is we use separator semicolon here. Like we use here. Okay, separator semicolon. So it has a separator semicolon there. Then row name false. So tak ada row name. Okay. There is no row name. Okay. Then go to the line 78. Okay. Then this is my text, which is title, extra line. Okay. Then we put no more line. Okay. So here, right line, my text. Okay. 7b.txt. Okay. Look at 7b.txt. What it look like? Here. Which is we create a file .txt 7b.txt. It is line extra, title extra line, then new line 2357, then new line. Okay, here. Okay, if you have later you have one data. If you want to quote the title for the data or something, you may use this right line inside your data. Okay. Then for exercise 8, here load my data. Okay. Then this is the random number generator. Okay. Then this is we create a data frame, new data. Okay, X, Y, and Z, and we save it. Okay, r.data, we save it as type r data, and rm my data, which is we remove rm, which is my data, and we call my data again. Okay, because it is not found. Okay, now you can see that if you save this data and you want to delete it by using your code, you can use rm, which is it is removed. You remove your data by using code, and there is no my data. Okay, then here we load exercise 8.rdata. Okay, then head of this data type, we can see the head of it. Okay, this is our exercise 8, the first item. Then okay, this is how we read Excel file. Okay, first you have to install package. If you face a error like there is no function or something like that, you have to do a install.package first. Okay, like this. Okay. In my R there is no read Excel, so I install it first. So after that, I may use read Excel here. If I don't have this package, I can't read my Excel. Okay, then before you use read Excel, you have to do a syntax library read Excel. Okay, now you may use that. Okay, wait. Okay, then this library built in our R. Okay, then here we can read Excel 3.xlsx. Okay, this is the my data, new names. Okay. Okay, so look at our head of this data. So here we instead of we want to see the first six item, we can also put 20 here. You may see the 21st, which is first 20 data. Yang pertama, 20 data yang pertama. This is the data look like. Okay, from the exercise 3.xlx. Okay. And my data x1. Okay, this is the real data look like. So it involves how many column there? 100. But here we only want to see first 20 data. Okay, so it appear here. Okay, then finish with read data. Okay, so far so good. It's all about R. Is it okay? Oh, select post line. Sorry. Okay, just now the Isa say about Sims problem. Okay, so can we move to the next slide? Is it okay? For data cleaning. Okay, getting and cleaning data. Okay, for this, sometimes we have to do cleaning data. Previously, we only read and write file. If you want to save file, what you are going to do. And here you can read and clean your data, which is you want to clean it or you want to tidying it based on your preference, which is, for example, if the data combine date, month, and date, month, and year, you prefer to look at your data by year. So you have to separate the data in terms of date one column, year one column, and date one column, so that you can determine the year involved. You have to separate it. Okay, this is what we call how to clean our data based on our preference. Okay, meaning of data quality. What is data quality? Okay. Generally, you have a problem if the data doesn't mean what you think it does or should do not up to spec. Okay, you don't understand the spec. Okay, many source and manifestation. Okay, this is the meaning of data quality. And data quality problem are expensive and pervasive, which is data quality problem costs hundred of billion each year. Resolving data quality problem is often the biggest effort in data mining study. If you uh, get involved in this data cleaning, uh, uh, you may do a freelance to clean all the data that your client want, then you may uh, make it as your freelance work. Okay, you already master for cleaning data, so your job is only to clean the data. Okay, for example here, can we interpret the data? Okay, what does the field mean? Okay, if our data like this, we want to separate it. Okay, this mean a T does that J is what mean. Okay, we want to clean it or we want to put title of this data. We want to separate it. This is what the cleaning and tidying data do. Okay, data glitches. Oh, ini apa? Typos, multiple format, missing default value, and metadata, domain expertise. Okay. For example, field 3 is revenue in dollar or cents. Huh. Okay, field 7 is uses. Is it censored? Okay, field 4 is censored flag. How to handle the censored data? Okay, then the data glitch. This is systemic change to data which are external to the recorded process. Change in data layout or data type. Okay, integer becomes string. Swap the field. Okay, this is how the cleaning data involved. Okay, change in scale or format. We want to do dollar versus, for example, dollar versus euros, and temporary reversion to default. Failure of processing step, missing and default value. Okay, gaps in time series. Actually, the lot of work while dealing with the data is in this part. Okay, which is we have to make our data to what we are want to analyze. Okay, first, okay, then we look at the conventional definition of data quality. Okay, and this is the accuracy, the completeness of our data, the uniqueness and timelines. The data is kept up to date and consistency. The data agrees with itself. Okay. And the problem here is unmeasurable. If you have data, accuracy and completeness are extremely difficult, perhaps impossible to measure, and context independent. No accounting for what is important. If you are computing aggregate, you are can tolerate a lot of inaccuracy, incomplete data. What about interpretability, accessibility, metadata, and analysis? Sometimes we just collect the data from like we have a IoT device, then we collect the data. We don't know the objective of this experiment. Okay, so we have to know what is objective and what data we want to know, we want to get. Okay, after that, after we get the data, we will see what the how to clean that particular data. But first we have to know that our data is complete, which is it in our contact, which is we want for further analysis, it's complete. Okay. Then the conventional definition provide no guidance toward practical improvement of the data. And for the data cleaning, okay, this is data scientists spend about 80% of their time cleaning and manipulating data, and only 20% of their time actually analyze it. Okay, we have a lot of tools to help us to analyze it, but for this cleaning data, we have to involve it by case, which is this type of data that we have. This is the process that we have to do. It's like case by case, but to analyze it, we already know what tools that we're going to do to analyze it. And it is critical to become familiar with the data cleaning process and all the tools available. Okay, then basic introduction to cleaning data in R using the tidying, deployment, deployer, lubricate, and string package. This is the package that you will use to clean the data. Okay, then focus of this chapter is to explore the raw data, tidying our data, preparing data for analysis, and putting it all together. Okay, then you can see that we have about 145 slides. Okay, just skim through what we are going to do in the R later is, okay, if we have messy data, X column is just the row number, they are spread but should be part of date field. Okay, this is messy data, days are spread but should be part of the date field. Okay, and year and month, they should be one column. Measure are melted but should be each in a column. Okay, that's what we call a messy data. And this is the raw data look like. We have like this. And this is the example of the raw data. Okay, look at this. We can see that from line 281, there is a lot of missing value, which is we can remove it. Okay, then this is our structure, which is the type of each column's mean. Okay, this is X7 is character, and month is in integer. Okay, this is how we want to know the type, data type. Okay, then we clean our data. Each row is daily record of weather. There is a lot of cleanup here. We will clean this data set in the last section. Okay, now this is the head of weather clean. Okay, this is the clean data. Okay, we already put the name for the head, and okay, and from here we can see the structure is more it's look like more meaningful for us compared to previous raw data. Okay, if you want to see the tail, whether it is involved missing value or not, you just previously we use head, right? We can see the first six data, but you can use the tail command to see the bottom line of your data. And this is look like more meaningful to you after we clean it. And this is how we explore the raw data. Okay, this is the class. We want to know the class. It is data.frame, and this is the dimension 119 times 30, and the column names for column name involved in this BMI data. Okay, this is the column name. And this is the structure, which is we want to know the data type. Okay, then glimpse BMI. It's also the what involved in each column there. Check the structure of BMI, the deployer way. Okay, then here, okay, this is the summary of BMI. Each column we can summarize based on minimum, first quartile, median, mean. We can get it from the R. Okay, on each column we can get this statistical measure value here. Maximum, minimum, first quartile, median, mean, third quartile here. Okay. This is look at your data. This is how we look at our data for the BMI. This is the first 6. Okay, you can see there is quite long of data. Okay, so here this is how we visualize it. We visualize it. This is the symbol of dollar here. We focus on year 2008. Okay, BMI for 2008. Okay, then this is involving the tidying data. Okay, here we have to install package TIDYR tidy. Okay, then in here we usually use gather, spread, separate, and unite. What is gather, spread, separate, and unite? It is here. Okay, for example here, if we have cases like here, from FRDEUS is here, and this is the cases we want to make this data clean based on year. Okay, for example here, okay, like it, slide. Okay, for example, this is the raw data. We want to make it like this based on year. This is the count and end. Okay, this is the first which is year 2011, and the end is 7,000. Okay, we want to make it like this. Okay, so we can see the based on year, the data change. Okay, okay, this is what we're going to do. And this command is getter, getter command here. Okay, from this kind of data, we want to make it as this key form a column name and this end value form a cell. Okay, here. And this is the command getter just now. Okay, then this is the description of the getter. Okay, then now you have like this pollution. How can we do it like this? Large, this is amount. Small London, okay, this is the amount. Then we want to make it, okay, like this, which is large, small. Okay, what we are going to do? Here, size, large, small. Okay, based on large and small, the size here. And this is the New York for the large and small. Okay, this is what we going to represent after. This is the raw data. We want to represent it like this. Okay. This is what we using the function spread. Okay. Okay, this is the spread information. Then you can gather it back to this. After you spread it, you want to make the to find the this kind of data, you can gather it back into this. Okay, then what is unite and separate? Okay, this is the raw data. The separate is we separate year, month, and day. Okay, we separate it from this kind of data. We can separate it by using separate function. Okay, then this is unite. We unite it back into date. Okay, So this is dplyr. What is dplyr? Select, filter, arrange, mutate, summarize. Okay, this is the select, which is we select only storm and pressure. We don't want to know about wind and date. Okay, then we use the select, storm and pressure. Then we want, this is pressure and date. And useful of this selection, you may use content. Okay, this is the information of each of the function there. Okay, then this is filter. We only want to see Alberto, Aliston, and Arlene. Okay, this is, we filter it. Okay, we filter it, which is, it is more and equal to 50. Okay, look at our data. We don't want to see the less than 50. We want to see the more and equal to 50 data. Okay, this is the command. Okay. And this is Tom. Okay, even though we want to see the more and equal to 50, but we want to see only for Alberto, Alex, and Allison. But here, the Alex one is not greater than 50, so it will not appear here because it is less than 50. Okay, then this is the logical involved like this. Okay, this is the logical greater and equal. Okay, this is greater and equal. Okay, then other than that is Boolean, exactly all. Okay, and this is mutate. How do you mutate the data? Okay, we mutate it by plus the ratio here. And then we mutate it by involve the inverse. How can we get the ratio and inverse here? By using this information. We find first ratio and second inverse by using all the information here. Okay. What is it just now? Ratio and okay, this is how you use mutate function, the command for mutate. If you want to do cumulative min and max, then you can do cummin or cummax. Okay. Okay. This is window function. Okay, element wise, what you are going to display. We are using this command, and this is for summarize. If you have a lot of data, you just want to know their median and their variance here, so you can summarize and select this median and variance based on amount here. Median of amount and variance of the amounts. You get these two column only from this a lot of data. Okay, then you can summarize also by finding the mean of amount and sum of the amount. Okay, here. And how many data involved? 1, 2, 3, 4, 5, 6 from n data. And useful summary function. This is the summary just now. And the first value in a vector, last value. Okay, this is the function arrange. You want to arrange your data. Then you may see this example, how they arrange it. Okay, so it arranged by, okay, decreasing the value, right? Based on the mean value, ini increase. This is how we arrange. This is by date. We arrange it. And this is the mutate. Okay, we arrange it by finding the ratio here. Ratio is pressure divided by wind. Okay, then here we only want to show the storm and the ratio. Okay, look at the syntax there. And so far so good. Okay, this is just the explanation about the slide. Okay, this is how we find the mean, sum, and from these 6 data, mean, sum. Okay, and here is, okay, from these 2, okay, we separate it, 2. Okay, this is New York, from 2 to, we divide with it. Okay, this, but you group it, then you summarize it. Then this is the function group by. This is, okay, group by. Okay, group by the city. Yeah. Then this is the pollution. You group it by city. And this is the summarize it by using group by city. Then this is the amount. And this is all the group things. And this is also you summarize it. After you group it, then you summarize it based on mean, based on their amount. Okay. This is how you ungroup again. After you group it, then you want to ungroup it, you can ungroup it. And it may look like this. Okay, this is group by year and country, country by year. And this is after you group it by year and country, then you summarize it by case. Some cases, okay, you summarize it. So for Afghanistan, the cases is 2 in 1999. And for 2000, it is also 2. You sum it by cases. Okay, then this is the hierarchy of information, which is based on the cases just now. We can see that the Afghanistan is 4 and Brazil is 8 and China is 12. Okay, then this is the multiplier. How can we bind column? It is we combine x1, x2 with z. It will look like this. Then here, if you want to combine it by after row, then it will continue below by row. Then this is the union. How can you union Y and Z? Because inside here is also have B and C, but here only have A and here only have D. Then you can union it without repeating the same value. You use the union. And this is the intersection, which is what the thing that intersect, the similar thing that repeated in Y and Z. Okay, there is 2 repeated thing, which is B and C. That's the intersection means. And this is the set difference. We want to know the difference between Y and Z, and there is Y involve A, but in Z involve D, but it is not in Y. Okay, then this is left join. We want to join based on their name, Josh, John Paul. Okay, this is the place, Sita, guitar, and bass. Okay, now because of Peggy is not in this name, so for the place for Peggy is NA, missing value, because there is no information about Peggy here, but there is information about Paul. You can edit here by using left join. Okay. This is also the example of left join. This is the inner join, which is you want to put the song artist by their name. Okay, this is song, and this is the name of the artist, and he plays guitar, sitar, or bass. Okay, but it's only involve John and Paul only, because there is no artist name in Popeki here. Play what instrument here? Okay, so the complete data is from John and Paul. Okay, then this is semi-join, okay, which is we only take song and name. We don't use all the data, we only take what column that we want, the semi-join. Okay, and anti-join, which is, okay, we can see here Peggy and by body, which is not in here. And anti-join song artist by name. There is no Peggy in the artist name, so we just display Peggy Sue for the body. Then this is for preparing data by using the Blue Brigade installed package. This is the type of data student.rds, and this is working with date. Now we have the structure. we know that this is the data, what we call data type. Then here you can see that you just want to see this 7 September 2005. Okay, so this is past as date, which is we past as date and time. Okay, with no second. This is we do it. If we have these two, then using MD1HM here, we can get the data like this, which is this is date and time with no second. Okay, now we can name it as a student and date of birth. Okay, we can see the student versus date of birth only. Then this is the data for the student, the structure for the student. And this is the string one, package that work with the string. Okay, and string manipulation and finding and replacing string. Okay, this is how you replace. Okay, detect student date of birth on 1997. So for the true is there is data for the student in 1997 and false there is not in 1997. Okay, then we can replace sex here, the student in terms of their sex category, we want to put male. Okay, so instead of M previously, you can see the data, M for male, we want to replace it into MALE. So you use this command, replace it. So you can see here from F just now female, we want to put female. Okay, so it replace with female and the data M for male, we replace it with male. Okay, this is how we replace the category for students sex here. Okay, this is missing and special value. Okay, this is how we find the special is dot and a. It will come out if there is true, meaning that it involve the missing value data. If all the data is false, so meaning that it will not involved in missing value. For example, if come out with true here, meaning that there is uh, any missing value. So if the answer is true, so we can find that in the data there is missing value. Okay, here. Okay, this is the stable status. Okay, and definite, indefinite, and non-number. Okay, this is the explanation. You may go through of it. And if you want to dealing with missing value, there is a lot of cases, which is first, if you want to omit it, you can use it like this. You can omit it. For example, here we have data 1, 2, 3, 4 here. It involves Tom for missing value and Alice for missing value. We want to omit it, so you can find the data without that only from 1 and 3, Sarah and David, by using this command na.omit. So we remove all the missing value. We get the data without the missing value item. Okay, and this is the outlier and obvious error. Okay, we can look at it by using the summary. Okay, it gives the summary of our data. Then you may find something involved with error in your data there, or you may use the histogram here to know, getting to know your data. This is student based on their age. This is student based on absence, and this is student based on absent also, which is here, which is kita but force 0 to be bucket to the right of 0. We do some changes in the student data, and we plot it again, then we get this kind of histogram. Okay, then you can look also in terms of box plot and student based on their age. Okay, a strange value here. Okay, you can see there is a strange value here from your data if you visualize it by using the box plot and then putting it all together. Okay, so far so good. Macam it look like me talk alone, but we have to know what the purpose of why we are using the cleaning data. Okay, let's look at our R. Okay, the code just now is inside here, data cleaning, day 3 P8 data cleaning. Okay, yeah. Okay, if you involve with R and you want to clean all the environment here, you may use this broom. Clear it. Okay, are you sure want to remove all object? Yes. Okay, this is another thing. You can use this broom also, clear console. So our environment and our console is empty. Now, just use the broom. There. Okay. Okay. Are you good? Are you still with me? Okay. Let us continue. If you are tired, let me continue. But you can see from my recorded after this. Okay. Now here we use library, dplyr, tidyr, string, and lubricate. Okay. We run it. Then library. If your library dplyr is not there, can't find the dplyr, you have to write install.package dplyr. Also with tidyr, string, and the last one lubricate. These three package that you are going to use throughout this process. Okay, now, okay, this weather read rds data / weather dot rds is not inside. Okay, weather. Okay, it is inside our data folder here. Weather. Okay, it is inside that. Okay, so we can call it inside data, and it is inside folder data weather.rds here, where you can see RDS file here. Okay, we may use it. Okay, if you are in this session, you may run it. Okay, cannot find. Open the connection. Okay, let us go to the session working directory to source file location. Okay, so now we are from just now we in different folders, so we are in the D3 material here. Then we may run it. Okay, so it not appear error anymore because we are in the active directory. Okay, good. Are you good? Oh, doktor nak type apa tadi untuk install.package. Macam ni. Install. Sekejap, tak boleh tak? Sekejap. Install. Ni kat sini. Bila you type install.package, then it may appear here. Install.package, you may click, then put inside it dplyr. Are you good? Aiman? Error install. Maybe you have to put like this. Enter. So you can one more package to be updated currently loaded. Okay. So I will cancel it because I already have the deployer just now. May confirm it by running again. So there is no error for library deployer. So I already installed that particular package. If there is no deployer package, you have to type this: install that package deployer, install the package tidier, install the package string, install the package duplicate. Okay, it may take some time. Are you good? If all of you have to install the package, all these 4 things, I will wait for you. Or you already have it. We may proceed.
Yeah, Dr. Juzani, I think you can proceed because just now I also take very long time to download all the package.
Oh, okay. Yeah, you may see inside my recorded letter. Okay, that's the thing that you have to do. Okay, then if you have all the thing, then you can read this weather.rds from that particular folder. And if you want to see the type of your data that you going to involve is, you may see only the first 6 data. Okay, we can see that first 6 data involve year, month, measure, and it involve until column X31. Okay, you may see that this is the name of our column here. Okay, then you may see the last line of your data, which is tail. Okay, you may see here the last line of your data involve a lot of missing value. Right, and A. Okay, then if we want to see our structure of this weather, you have to put str weather. Just put it, then you may see each column, the data type of each column. This involve integer. Okay, then this is, we want to read a weather clean. This is the weather clean, the clean one. Okay, then from this clean weather, we can see that, okay, previously our data, the name of our column is only S1, S2, but here we already clean it. This person already clean it, then he name it each column to what is supposed to be, which is like maximum temperature, maximum visibility, okay, until wind degree here. Okay, then this is the tail, weather clean. Okay, then you can see the tail here, 366 from the raw data just now. Okay, this is the tail, 286. So the clean one, he add some point. So he joined something to the above data. Okay, then this is the structure of the clean data. Okay, now can see that it number previously it involved what? Character. Okay, this is character. That's why your number have the what we call the dot above here, because of it is character. And so it he clean it by change the character to the number on each column that he rename it. Okay. And if you want to read the BMI, like example in your slide just now, read it from RDS data type. And this is the class of BMI. What class of it? And it is data frame. And the dimension of BMI is 199 and 30 variable there. You can see here. Okay, 199. And there is 30 variable there. Okay. You may see that the data cleaning just now. And this is the column name for BMI. If you want to see the column name of our data, just put column name. Then this is the data name just now. We name the BMI.res as BMI. And this is the column names. And if you want to see the structure of BMI, which is the data type, can see that each column have the character data type, and each year here the data type is number. Okay, then this is load the deployer just now. Actually, we already load the deployer here. If you don't want to run it, it's okay. Okay, and this is the glimpse BMI. Just now inside the slide there is a glimpse, which is you want to know inside our each column there is this kind of data inside it, and this is the summary of each BMI column. Okay, you may see the summary, their mean, their median by using this summary on each column. And this is the mean. Okay, and if you want to see only the summary BMI for the year 1980, just put dollar sign and put Y1980 there. So you will see this only. Let us try. For example, okay, you just want to see this column summary. Then we may run it. Okay, this is the summary of that particular column only. Okay. And okay, if you want to print BMI to console, don't do this. It's just with space. Use the head, tail, string, summary function. Okay, no need to print all the BMI. If you call BMI only, it will display all the line of BMI. Okay, no need. You just see head, tail, and structure of it. Just enough. Okay, then for BMI, you just see the head, and this is the head of BMI. And you want to see the head for the first 15, just put first 15 there. Then the last 10 for BMI data. And this is the last 10. We have only 199 data. So the last 10 is from 190 until 199. And this is the histogram. We want to see the histogram based on the selected year only. So we may use this. So this is the histogram for year 2008. And here, how can we plot? Kita nak compare. We want to compare BMI from 1980 and then 2008. We will use the function plot. Okay. So this is BMI 2008 versus BMI at 1980. Okay. Then here we come to tidying our data. And first, the BMI data is already loaded. Package is already loaded because at the beginning just now we call the library.tidy this thing, right? Okay, we call this at first line just now. Okay, then we can see our BMI data. Okay, this is our BMI data, the first 6. And here, we name it as BMI long by getter only BMI year, BMI value, and country. Okay, so here is what we want to getter. And now we can see head of BMI long for first 20 row. Okay, instead of we have a lot of data here, we only gather country, year, and BMI value by using the getter function here. So if this is our preference, then we can call getter by look at only these three columns. Okay, then when we want to separate, what we want to separate? We want to separate BMI long. This is the BMI long data just now. We want to spread BMI long, year, and BMI value. Okay, look what will happen. Okay, this is the head of BMI wide, the separate function. Now, okay, this is the BMI long, year, and BMI value. This is the head of BMI wide. Just now. Okay, just now here we combine it. We look at year. All the year is there, and all the BMI value is there. But here we spread it back. Okay, based on year and BMI value. Okay, we spread it back. And this is how we read the new data, which is BMICC.RDS. What is this kind of data? Just look at their head data here. Then here, it is country ISO, and you can find there is Afghanistan AF, Albania AL, Algeria DZ, and their year and their BMI value. Okay, now we want to separate BMICC based on country ISO into country ISO. Okay, then we separate it by slash. Okay, so look at what will going to happen here. So we separate it here. Previously we have this, and we separate country ISO. And if we want to unite it back, we use the function unite. This is all the thing inside the slide. Just now we do it practically, and this is we unite it back. And the separator just now we are using what? Slash, right? This is slash, but here we use what we call this dash here. Okay. And this is new data census. We read it first because read RDS. This is RDS format. Okay, then we can see the head of this census. Okay. This is we get the census month, amount, and year. Okay, this is gather this kind of data, and then we can see the new census data will be look like this. Based on year, month, and amount. Okay. Then we arrange it census 2 by year. Okay. And look, the first 20 data will be look like this. That is arrange it by census 2. We call census 2, then we put year. And this is census long name by using this census long data. Okay, so until here, we already know how to read data from our folder. Okay, this is from the RDS format, and this is how we call it. And we can see their head, the same process. How can we export our data? We can see the head is up to you whether you want to put by default, you only want to see 6, or you want to put it as 50. You want to see the first 50 data. You have this. Then this is how you spread it. Kita pecahkan dia based on type and amount. And this will be look like this. For the 20 data, we spread census long, type, and amount. The type is high, low, and medium, and each of this has its amount. Okay. Then this is census long 3. Okay. From the this file from the folder just now. Okay, and this is the head of this data. It will be look like this. Okay, you can see there's a combination of data there, and you can separate it year and month here. You can separate it into census long for here. You separate year and month, and this is the new data will be look like this, year and month. This is how we tidying our data, and this is class to evaluate the character. Make this evaluate to evaluate the character as character. We want to know the class character. Is this true? Okay. Okay, there is character class there. Okay, we want to see a class numeric. Is there any numeric data? Okay, yes, it has the numeric data. And is the class factor? Okay, then it involves factor also. And is there any class of logical there? Okay, yes, it has logical data there. Then if we want to, okay, this is how we want to see the data type for student. Okay, okay, this is student file from the folder, and we preview it by using their type structure, and we know that school as a factor, sex is a factor, age in the data type integer, address as a factor. Okay, then we want to cause grade to character. First we see our grade here. Where is the grade just now? Grade. Grade is a factor here, but we want to make it, we want to change it into character. Okay, then we use this command. Then we want to change the main to here, integer. We want to change it into as a factor. Okay, then another thing is to here, integer, we want to change it into factor. And look our data type, new data type, which is the grade has been changed to the character type, and Medu and Fedu just now as a factor. Previously it is integer. Okay, so far so good. Is it okay, right? So how to change the type of data, and this is the example. We see the structure first, then we want to use the Lubridate package. Okay, then if you already load the library for Lubridate at the first just now, you just use it, then pass as date dmy, we pass as date, and this is the date, and this is pass as date and time. Okay, with no second. Okay, then this is the new type from July 15. It will be in this kind of data, and here student date of birth. Okay, and this is the just now nurse visit. Okay, we name it as student. Then we look at the nurse visit data only. Okay, then this is the new structure of this student too. Nurse visit format, this new format with no second. And just now the new format of the TM just now pass as date. Which one? This is great. Yeah, okay. Because of this DMY deposit as date. Okay. Then we after this we put it as a this kind of format. Okay. Then it will change it into here. Okay. Then the string package is already loaded for the first time just now. And here we use string trim. Okay, trim all leading and tailing white space. Okay, we have this. Then we want to make it like this is Philip. Okay, Philip, it has a space, so we trim it. We remove the space in front and at the back. Okay, then it will look like this. Then we pad this string with leading 0. Okay, we run it. Okay, then we pad it. Okay, now we can see that there is 9 width or all the 9 length, and for the left side, the missing one, we pad it with 0. Ditambah. So if you have one column, the length of the data is different. You want to standardize it by using 9 width of number. So you may use padding here. And this is we create a state by using this. Okay, now we use topper state. Okay, topper function for this state. Okay, then you can see the new state upper. Okay, now you can see from previously the data is look like this. AL, okay, from the lowercase, so it all will be the uppercase. We change it into uppercase, all the data using proper function. If our data have country name in variety of upper and lowercase, you may standardize it. Then this is the head of student 2 just now. Just call it back. Okay. Then this is by looking at the date of birth. Yeah, date of birth. We want to detect only in 1997. Okay, if you want to look at only in 1997, this string detect will come out with true for only that particular year. False is not in that particular year. Then here, we want to replace from the sex just now, F as a female, we want to replace it by using the full sentence, female. Okay, this is how we change our value inside our data. Okay, for the sex inside student data, we want to change male into male in the complete word. Okay, this is male, and we can see head of student 2 now. Can see male and female here is in the complete word. Okay, like in a slide. Apa described just now. Okay, now we name this data as social underscore df. Okay, now this is we want to find the is.na is something like missing value. We want to spot, is there any missing value in this kind of table? Okay, so we can see there is missing value there, which is it is true. Okay, if it is true, we want to find the specific on that particular missing value. It is in 1, which is true. Okay, so this is the summary of that. Okay. List Sarah. Okay, this is this, and we have the NA value. It is 1 there. And this is the table of that based on the status. Okay. We're going to look at social underscore DF based on their status. Okay. And for this status, we want to find the status that replace all empty string in with NA. There is empty string there. We want to replace it with an A. Okay, then we can print all social TF just now. And here, if there is missing value there, it put an A. Okay, then this is the complete cases of social TF. Okay, then there is true, false, and there is involved here. This is true and this is false, and okay, this is true, false, and this is true and this is false. Okay, use complete case to see which row have no missing value. Okay, so no missing value will be true. Okay, so because of this is missing value there, so it is false. Okay, 1, 2, 3, 4. Okay, so it is like this. Sarah, first row, it is true. And Tom, the second row, it involves missing value, it will be false. And David, it is true because it not involve the missing value. And for the first one, it will be false. Macam tu. And here we omit the NE, which is missing value. Kita buang. Okay, so bila kita buang, when we remove it, we only have Sarah and David in this particular table. Okay, then look at this. What we are going to do, we want to see the summary of student 3. Okay, because I only highlight S, so it only run for S. So make sure that our cursor, whether it is all in front or back, or you highlight all the line. Okay, and this is the histogram student in terms of their age. Okay, then we want to focus on the student on in terms of absent student. And this is, we put 0 to be bucket to the right of 0. This is like the slide just now. And we want to see the last one here is, we want to see the box plot of student age. If you want to see the outlier there. So here is based on their absent. So there's outlier there. And we want to find, another thing is we want to find data frame. Verify this data frame. Okay, this is class data frame for the reader. Okay, and the dimension for the reader just now is 286 row times column 35. And this is the column name of the reader. And this is the structure for the reader data type. Okay, then we want to do a glimpse. We want to look at what is this each column value. Okay, we use the glimpse. Then you may see all these character. Then this is the summary of each column for the weather. And want to see the 6. Okay, it's look like it's repeated the same process, which is we want to see the 6, the 15 for the head and the tail just now. And this is the tail of from the 10 last value, which is involved a lot of missing value. Okay, now we want to do a getter for tidying the data weather. For column X1 until 31. Then we want to remove all the missing value. NA.rm is remove the missing value. Okay, then this is the head of weather 2 will be look like. Okay, now we have Monday, and this is the value. And we remove the column of row name. We remove it. Okay, and then we spread whether there is measure and value. measure and value for the weather too. We separate it, we spread it and look at the new data weather tree will be look like. Okay. Then we spread. Just now the measure will be replaced with the CXT1 X1 until X31. It will replace with measure now. And then this kind of value of each measure there. This is the head of weather tree. And here we want to replace each weather tree with X. Okay. So here, look. Okay. So here, head of weather tree 1 until 5. Okay, look what we have here, which is we cloud cover weather head weather tree. So this is weather tree. Cloud cover. Okay. Then it is year, month, day, cloud cover, and event, which is we do 1, 2, 3, 4, 5. We only have this. We want to see 1 until 5 for the head. We don't want to see all the X value there, measure there. Okay, this is the column 1 until 5 only. Okay. Then we use unite year. We want to unite back the date, year, month, day by separator dash there. With the 7. Then this is the head over the 7. We unite again. This is year, month, and day. This is how we unite it again. First is we separate it, we spread it, and then this is we unite it again. Then this is YMD, convert date column to proper date format. If you want to convert it to the proper date format, okay, then use this command. Then you can see weather for 1 until 5. Okay, this is the format in the date format. Okay. Then this is weather 5. We want to select only weather 4, date, event, cloud cover, and this is the wind directory decrease. Okay. So we only want to see that. Okay, we can see from the head. Okay. Wind directory decrease. Okay, then this is weather 4, date, event. Okay. Okay, so this is all the data type of weather 5. Okay, you can see this is the data type of weather 5, which is it involves date format. This is the format for date and character for each component. And this is the head for first 20. You can see that. Then you want to make as numeric for precipitation in. Okay, look back. Precipitation. What we call it here? Precipitation in. From character, we want to make it as a numeric. We want to change it, the data type. Then, warning. Introduced by coercion is okay, but we already make a change for this kind of column by using numeric. Okay, because of it involve NE. Okay. So now, here, whether string replace whether T and 0. Okay. So whether 6 we mutate it. What is mutate just now? We put some value based on the current value inside the table. Okay. Okay. Find multiplicated multiplier 0 and please use list either function or lambdas. Okay, function of lambda. Okay. Simple list, please use list either function or lambdas. Table mean median. Okay, it's replace one every 8 hours. Okay, this one is me. Okay. It's okay. So we can see the data type of weather 6 here. Precipitation just now is already changed into number. And we mutate the data 5 previously. There is something that we add from data type 5. Okay, may look back this kind of data type 5. Okay, we add something, the mutate value based on the current value. Then this is how we count a missing value in data in the weather 6. We want to sum the missing value. Okay, there is 6 missing value. Find index of value, missing value in max gas speed mh. Okay, so we want to find in this column only the missing value. Okay, now we can full of row that contain the missing value. Okay, so here there is here missing value in this max gas speed mph. This involve missing value in this particular column. Okay, so this is a summary of weather 6. Okay, we can find that just now the missing value inside the max gas just now here, which is an 8, which is it has 6. But for the other column, there is no missing value involved. You may see from the summary. Okay, and this is the max. We want to find the humidity is equal to 1000. Is there any humidity equal to 1000? Okay, we can look at that particular data. Okay, this only involved is for humidity is equal to 1000, and for humidity equal to 1000 just now, we want to make a change for it. Okay, here we change from 1000 to 100 for that kind of data. We find back this. Okay, we change it into 100. 1000 data just now, we change it into 100 here. Okay, then this is the summary of weather based on mean visibility. Okay, we want to look at this summary only for this column. Then this is the column which is it is equal to -1. Focus on that column, and we want to set to the appropriate value. Visibility mass is equal to -1. We want to set it as equal to 10. We can change it. Okay, we don't want to use to do it manually, so we can change it by using this particular command. And this is the summary of weather 6 just now. Okay, and this is the histogram of weather 6 on mean dew point TF column, and this is also the history based on mean temperature F, and this is the histogram for mean temperature F. Okay, this is how we clean our column name. Okay, this is the new column name. We name it, okay, as new column name, and we name new column inside this weather 6. Then weather 6 for the event, it will be look like this. And this is the head for the weather set, which is it already replaced with the new column name that we changed just now. Okay. Alhamdulillah. So we finish our class. It is a quite a long exercise actually, but when you do the lab exercise, you may see all these command that you will use. Which one is more appropriate to your cases, you may use it. Look back for my class here, how to clean and tidy in your data. Okay, are you good? Semua dah tidur. Okay. Okay, Alhamdulillah. Managed to finish it. Okay, so this is all about tidying and read our data. And after this, you may see the lab project, which is lab assignment. You have to clean the data. Actually, there is one question about to read and clean the data to find a missing value. You may look at it, look at that exercise, then you may finish it. And after this, my part is to cover on the analysis of variant. There is only one topic, but in that kind of topic, it will separate in 2 sessions because there's content about 80 slide, but we have exercise also in R. Okay, and there is question also regarding that particular topic, analysis of variance. We want to analyze the difference between value, which is variance, the variance. Okay. Until then, is there any question? Are you good? Okay, if there is no question, I will stop here. Is it okay? Okay, so we will stop here because we only cover for clean, read and write data for today. So next week we cover on the fundamental side of statistics, which is analysis of variance. So until then, we continue next week on Tuesday with analysis of variance part 1. Okay, you may see all the recorded for today class. After this, I will put it tomorrow morning because it will take time to me for the way back to send back this recorded for me, and inshallah I will put it tomorrow. Okay, see you next week.
Thank you, Doctor.
Thank you.
Thank you,
Thank you, Doctor.
Doctor.
Bye-bye.
Thank you. Bye bye.